Okay, welcome back, everybody. Welcome to our last chapter. Yes, it must be true. All good things come to an end. So now we're at the end, but don't stop early, please. This chapter is as important as any that we've done so far, since we all live in a world of wireless and wired content. So all of this is making us more productive at work and gosh, improving our fun life too, I hope. So, not just a quick story though, I just wanted to share this. About 3 years ago, I was installing web filtering in the former Time Warner cable that was acquired by my company. And so some of the employees in Time Warner who had never had web filtering thought that they should reach out and let us know by the ticketing system what they thought of IT security, right? And so one person writes, I love this new web filtering software. I used to spend all day on Facebook and now I can't. I can now finally be productive. Thanks, IT security. Of course, they're being sarcastic, I assume. Maybe not. And another one wrote, gosh, I am so glad you blocked me from watching YouTube. Now I can actually listen to my customers' needs. You're the best, IT security. Well, that's what we do. And that is in both wired and wireless communications. So, simply said, we're talking now about digital communications, which involves an organization's online communication efforts. Most organizations today use a wide range of online channels, right? And your company or your home network, no different. From their website to mobile chat to blogs, to connect with current and prospective customers, employees, other stakeholders like family members, right, and friends. So inside the company or the home, locally or globally, this is an internal and external view of where we sit, right? This involves both wired and wireless digital communications. Examples include email, cell phones, video conferencing, instant messaging, text messaging, blogs, and wikis, for example. Now, to communicate, you need to have a couple of things. One, you need a sending device to send the data, instructions, and information, right? We've been talking about that this entire class, to send data, instructions, and information. Then we want to connect to a transmission media, which is going to be some comm channel that we use. So our device connects to this transmission media. And then we have to have a receiving device that accepts the, oh yeah, you guessed it, data, instructions, and information. So the earliest examples of computer networks are from the 1960s, but they have come a long way in half century since then. A computer network is just a series, a set of computers that are connected together with these communication devices and transmission media we just talked about so that they can share information. Now this is going to involve the intranet or internet. We'll discuss these shortly. Listed in this slide are advantages to creating one of these intranet or internet networks. And you could find more on this on pages 10-3 and 10-4 of the book. A value-added network, or VAN, is just something I want to touch on. This is a third-party provider business that's going to give us that networking services, such as EDI services. Some VANs, this value-added network, such as PayPal, they'll actually charge an annual or monthly fee. Said another way, maybe to put it a little differently, a value-added network is a private hosted service that provides companies, or your home if you want, with a secure way to send and share data with its counterparts. Now, compared to a manual processing system, a VAN reduces the costs associated with business communications. It decreases the need for paper transfers, allows tasks such as ordering inventory or processing payments to be completed more efficiently through an electronic means, as I mentioned, PayPal, for example. Okay. Now, an intranet, I wanted to do that first. An intranet is a private network that can only be accessed by authorized users. The prefix intra, it means internal, and therefore it implies an intranet is designed for internal communications. For example, a business may create an intranet to allow employees to securely share messages and files within each other. You notice the building on the slide. A local area network can be part of that. A local area network is a collection of devices connected together in one physical location using cables such as DSL. We'll talk about that later, the types of cabling that may be run throughout the building or an office or a home. Now, in contrast, a wide area network or WAN, or even a MAN, meant to mean a metropolitan area network, this covers a larger geographic area. Now, some WANs and MANs, they'll connect many LANs, these local area networks. So a wireless local area network now is a wireless computer network that links two or more devices using wireless communications, such as Wi-Fi. You notice that on the right-hand picture in the middle, Wi-Fi. And so this is going to form a local area network within a limited space, such as a home, a school, a computer laboratory, campus, even an office building. So your home network for your course project would probably show a wireless LAN also. Now, Wi-Fi and wireless LANs are not the same thing, just to touch on that. Wi-Fi refers to wireless communication. You see that with the signals going out in the picture on the right. While a wireless LAN uses that communication in the local area network, hence the name wireless local area network. Okay. Now, compared to a LAN, a MAN, or a metropolitan area network, is a larger network that usually spans several buildings in the same city or town. Often these are managed by some consortium, and a MAN is a class of this network which serves a large geographical area from maybe 5 to 50 kilometers in range. As opposed to a WAN, a wide area network, in comparison to a MAN is not restricted to a geographical location, although it might be confined within the bounds of a state or a country. A WAN is wired and wireless also, and a WAN connects LANs and MANs. Now, there's also a PAN, or a personal area network. This is a network that's concerned with the exchange of information in the vicinity of a person. Typically, these systems are wireless and involve the transmission of data between devices such as a smartphone, a personal computer, or tablets. You may have a PAN at home. And finally, just to add one more, there's a BAN, a body area network. This is BAN technology is the use of small, low-power wireless devices that can be carried or embedded inside or on the body. And it's sometimes applied to health and wellness monitoring, sports training, etc. If you do a stress test, you may be connected to a body area network. Now, the configuration of computers, devices, and media on a network, this is sometimes called network architecture, right? Two examples of network architecture that we're going to talk about are the client-server network, and the other one is the peer-to-peer network. So a client-server network is the medium through which clients, you and me, access resources and services from a central computer, either via this local area network or via a wide area network, such as the internet. Inter meaning between, right? Between nets. So two views are presented in this slide. The architecture, I just want to note, will connect, this client-server network is going to connect more than 10 computers generally. And it's going to use a network administrator. There's a new position, a new term now, which we'll discuss shortly. Some servers will be dedicated on this client-server network, such as a server manager, network server manager. And a network server manager is going to do what the name says. It's going to manage the network activity or the traffic to make sure it doesn't clog up. Or another dedicated server on this client-server network might be a web server to deliver your requested web pages. Now, in Windows 7 and Windows 8.1, I think, when you create an ad hoc network between two computers, you create a peer-to-peer network between them, right? Sometimes known as a home group. A home group is a small group of computers connected between themselves to share storage and printers. This is one of the most common uses for the peer-to-peer technology. And it can be done by connecting a couple of computers via maybe a universal serial bus to transfer files. Now, this is ideal for small businesses. So a peer-to-peer network usually connects 10 or fewer computers to share the data, to share hardware like a printer or other information. Now, peer-to-peer file sharing describes a network architecture configuration as a review that allows users to access one another's hard drives and exchange file directories via a file sharing program. So communication software is used to provide remote access to systems and exchange these files and messages in text or audio or video formats between these different computers or users. The best defined examples of communication software are FTP, as you recall. That's File Transfer Protocol. We talked about that earlier in the course. This is a good example of communication software using the FTP. As a reminder, this protocol is a set of rules that networked computers are going to use to talk to each other, right? We have to know the rules. How can we communicate the same language? So an FTP is the language that computers on a TCP IP network, for example, such as the internet, use to transfer files to and from each other. Other examples of communication software include messaging software, and like instant messaging and email software. Now, various organizations such as ANSI, that's the American National Standards Institute, or IEEE, that's another one, it's the Institute of Electrical and Electronics Engineers. What they do is they propose, develop, and approve network standards. And a network standard provides these guidelines now that specify the way computers are going to access the medium, what speeds are used, the hardware, the software. These people, the manufacturers, are all designing their products to meet these guidelines. So a standard that outlines these characteristics of how these devices communicate is called a protocol. Specifically, a protocol may define data format, coding schemes, error handling, the sequence at which the data transfers over the network, etc. Now, the picture on this slide is from Vaughn Aubuchon, and he has some one-pagers that he advertises. You can go to his website and download them if you like, I think for a fee. It's a brief summary. It's kind of a tutorial chart of computer network standards, summarizing the differences between LANs and WANs, right? Including internet protocols, OSI layers, and other computer network terminologies and technologies. It'll even include a glossary of terms, networking and computer terms. That's not for this course. That's beyond this course. It's just very interesting. And if some of you want more information, that's a good place to find it. Now I'm going to take a break there, and we'll come back with network communication standards and protocols some more.